Behind every single swipe, every click, every command you make on your phone or your computer, there's this invisible conductor making it all work together in perfect harmony. Today, we're going to pull back that curtain on the single most important piece of software you use every single day, the operating system.
So let me start by asking a question. What in the world is the common thread that links the phone in your pocket, one of those four-legged robot dogs you see running through a forest, and a scientific rover that's literally exploring the surface of the moon? I mean, they seem like they're from completely different universes, right? But they all share a fundamental piece of their DNA.
And the answer, of course, is the operating system. It's this powerful, totally hidden piece of software that brings all the hardware in these incredible devices to life. It's what allows them to perform their amazing and wildly different jobs.
Okay, so what is an operating system, or OS, at its core? Well, think of it as the ultimate bridge. It's the master software that connects the physical hardware, the chips, the memory, the screen, with the apps you actually want to use. Its main goal is just to manage all of the computer's resources to create this stable, predictable environment where all your programs can run smoothly. To really get a handle on what the OS does, it helps to think of it as having three massive, nonstop jobs that it's doing every single second your device is on. So let's break those down. First up, the OS is the ultimate resource manager. I want you to imagine a super busy office. You've only got a few meeting rooms, just one printer, and the coffee pot is always low. The OS is that indispensable office manager who makes sure everybody gets what they need exactly when they need it without the whole place descending into total chaos. And that management role goes deep. The OS is constantly juggling the computer's memory, deciding which app gets a slice and for how long. It's scheduling time on the CPU, the computer's brain, so every little task gets its turn to run. It controls all your devices, from your keyboard to your printer, and it organizes all your data into those files and folders so you can actually find anything. Next up, job number 2. The OS is an absolute master of multitasking. The reason you can be listening to music, browsing the web, and getting email pop-ups all at the exact same time, that's not magic. That is the OS working like crazy behind the scenes. To make all that happen, the OS is constantly creating, running, and then ending thousands of tiny little processes. It juggles them with incredible speed, switching between tasks so fast that it creates this perfect illusion that everything is happening all at once. It's basically a high-speed traffic cop for all of your digital information. And finally, the third big job, the OS is both a guardian and a guide. It protects your whole system from threats, but it also provides the very interface that lets you interact with your machine in the first place. It's what handles your security, right? Using things like passwords and firewalls to keep your data safe. It gives you the user interface, whether that's the graphical world of windows and icons or, for the experts, a powerful command line. And it's always monitoring for errors, trying to catch problems before they can cause a total system crash. But these modern, slick operating systems didn't just appear out of nowhere. Their history is this really fascinating story of evolution, tracing a path from people literally moving cables by hand to the incredibly sophisticated systems we use today. The story of the modern OS really kicks into high gear back in 1969 with Unix at Bell Labs. This was a complete game changer. Then a key innovation lands in 1973 called pipes. Think of it like a digital assembly line. It let one simple program do its job and then automatically hand off its result to the next program. You could chain them together to do really complex things. By '79, a more powerful command shell made the system even more flexible. And today, well, the core principles of Unix are alive and well in systems like Linux, which is the foundation for countless servers, almost all Android phones, and so much more. But the OS isn't just for our laptops and phones. In the world of robotics, specialized operating systems are pushing the absolute boundaries of what's possible, and they're doing it in some of the most extreme environments you can imagine. So I want you to meet ROS 2, the robot operating system. Now, it's not an OS in the way you might think, but it's a super flexible framework that's built on top of a standard OS like Linux. It's designed specifically for the complex communication and modular parts that modern robots absolutely demand. And here is a fantastic example of its power. On land, you've got robots like the Vision 60 from Ghost Robotics. They use ROS2 to process all their sensor data and plan their movements, which lets them navigate this treacherous, uneven terrain where a wheeled robot would never, ever be able to go. Then we go to the sea.
Mission Robotics uses ROS2 as a kind of common language for their submersibles. This means customers can easily just plug in new cameras or new sensors for a specific mission, whether that's inspecting an underwater pipeline or mapping a coral reef, all without having to rebuild the entire system from scratch.
And in the air, companies like Autorion rely on ROS2 for their drone software. It gives them these powerful tools for simulating flights, logging all the data, and making sure the incredibly complex systems you need for autonomous flight are both safe and reliable. And if that wasn't enough, we go to space. NASA's upcoming Viper moon rover uses ROS2 for its entire Earth-based command and simulation system. This means they can test every single command and simulate every possible scenario in this high-fidelity virtual world before they ever send a real signal to the moon. How cool is that? Even these specialized systems have to evolve. ROS2 was a complete redesign of the original. For example, it moved away from a centralized network, which had a dangerous single point of failure, to a much more robust peer-to-peer system, where robots can just discover each other directly. It also added commercial-grade support for embedded systems. These were absolutely crucial upgrades needed to build reliable, production-ready robots. So, where do we go from here? We've seen the OS manage our computers, we've seen it command robots in space. The next great leap, it seems, is to make the operating system truly intelligent and truly personal. This quote from a recent research paper just hits so hard. It says that for all their power, the core design of operating systems hasn't really changed in decades. They've been built for general-purpose computing, not for a truly personalized user experience. And that leads us to this incredible new concept, Peros, a personalized operating system. The whole idea is to bake the intelligence of large language models, the same tech behind tools like ChatGPT, directly into the very core of the OS itself. Here's the fundamental difference. A traditional OS is one size fits all. It's got this rigid interface that forces you to learn its logic to find what you need. A personalized OS would be the complete opposite. It would be adaptive. It would learn your individual patterns. So instead of clicking through endless menus, you could just have a conversation with it, simply telling the OS what your goal is. And that leaves us with one final big thought. We are moving from a world where we have to adapt to our computers to a world where our computers are finally going to adapt to us. So when your operating system is no longer just a tool, but an intelligent, personalized companion that truly understands you, what new possibilities will that unlock? What will you create together?